nuclei in a couple of different places. I'm gonna do it first on the easier model and then on the more detailed model. If you open up the brains and take the seahorse out, you'll see that he has this kind of egg-shaped lump on his head, this whole thing. This entire egg is the basal nuclei. So we're looking at it straight on right now. So this big egg here, with fleeing brains around. So here's the basal nuclei. There's two parts to it, and you'll notice that there's a part that's medial and there's a part that's lateral, and it's divided by this white mohawk looking thing, this white line that kind of cuts right straight through the middle of this thing. So the medial part here, that's called the caudate nucleus. And the lateral part is called the lentiform nucleus. So the medial is the caudate, lateral is the lentiform. Now the lentiform has two parts to it. The putamen is the part that you can see here on this model. So this is the most lateral of the lentiform, is the putamen. Deep inside, like an egg yolk, is the globus pallidus. So together, the putamen and the globus pallidus make up the lentiform nucleus. On this model, you can see the putamen part of the lentiform nucleus, but you can't see the globus pallidus because it's inside of here. And then the last part of the basal nuclei is the internal capsule, and that's the white stripe. Goes all the way around the back here. So you've got the caudate nucleus, the internal capsule, and then the lentiform nucleus. What you're looking at here is the putamen part of the lentiform nucleus, globus pallidus inside. Now there are brains on little stands. They're just kind of pink brains with no color to them at all. If you open them up, they're like a little puzzle. And you'll see this thing inside. So it's got, this is the brain stem. You take it apart and you can open this up and you can still see the seahorse here. So there's the seahorse's head and his nose, and this egg here on his head, that's the basal nuclei. You can pull this off, so you can just see the basal nuclei by themselves. So what you're seeing here is the caudate nucleus. That's the kind of tadpole looking thing. That's still the most medial part. And then you can see the putamen out here. That's part of the lentiform nucleus. And on this one, you can look inside and see the globus pallidus. You can see it's a kind of different color red inside of there. And as for the internal capsule, that would be these. So that would be sticking up, separating the putamen from the caudate nucleus. Okay. So you've got the basal nuclei, still medial. The putamen is the most lateral. Internal capsule separates the two. Open it up. There's the globus pallidus. Everybody see that? Okay, one more way we can see these, and that's from the real brain, which looks exactly like a picture in your book. So this one is easy because you have a picture in the book that looks exactly like it, and it's one of the pictures that was assigned for this exam. If you look closely at this, you can see the cerebral cortex is this darker outer layer, so you can see that it really is, you know, cell bodies are darker. The cortex is darker, and here's axons inside of here. But the basal nuclei is this right here. You see a little darker spot, that's where we have cell bodies. There's another darker spot out here with cell bodies, and a white stripe down the center. So what's that medial darker spot called? The caudate nucleus. Good. So this is the caudate nucleus. What's the white stripe?
capsule.
Internal capsule, good. And then the outer, that's the lentiform nucleus. I won't ask you to determine or distinguish between putamen and globus pallidus on here. Just lentiform nucleus will do for this. Okay, does everybody see that? Okay. Okay, for the white matter tracks, remember white matter, those are axons. So white matter tracks, or they could be referred to as white matter fibers. I might use either word on the test. These are just clumps of axons running in a particular direction, or groups of axons. The direction they go in is going to determine their name. You have projection fibers, or tracks. These run up and down. So they're vertical, they project up and down. An example of that is what we just saw, that's the internal capsule. So if you look at the internal capsule, you can see it going up and down. That's why it is a projection fiber or a projection track. So I might point to the internal capsule in any of the three places that I showed it to you, and you could just name it as the internal capsule. I might say, what type of white matter track is this? And then you would say a projection track or fiber. Or I might say, give me an example of a projection track or fiber. You would say internal capsule. So it could be asked as a question. Association fibers are also called arcuate. So either term is fine. These are very, very short. They stay in the cortex, and they stay in their hemisphere, so they don't cross from one hemisphere to another. So these are not going, there's not going to be any named ones of these. They're too small, so there's no example of those. This would just be a straight definition here. And the last one are the commissural tracks or fibers. And these go horizontally, and they cross from one hemisphere to the other one. And the example of this is the corpus callosum, which we haven't learned yet, but we're about to. It's the biggest commissural track or fiber that you have. It allows your right brain to communicate with your left brain. And if we look on this glass brain, you can see it as this big bridge between the two. So that's the corpus callosum. Now, this isn't just a thin little piece. This goes way forward and way back. So it's running the whole length of your brain from front to back. So it's not just this little strip here. It's coming all the way out and going all the way deep inside. So we can see it on any seahorse or any sagittal section. It's this top piece right here. Not this and not this. There's three things there. So it's this top one. So if you think of the seahorses wearing, if you ever like watch old movies where they have like the Roman soldiers and they have those helmets that stick up like a big plume, it's like the top of that big helmet. So that's the corpus callosum. So you can see how wide it really is. Now right below that is a piece of tissue. It's a very thin one, and it's called the septum pellucidum. And you can see that on here also as this little flap of tissue between the two holes. So you see these big spaces that look like a butterfly right in the middle of the brain. It's that little flap of tissue right between the two. Those two spaces, by the way, those are the lateral ventricle, or I'm sorry, the third ventricle. Okay, so it could be here too. Then this piece right below it, so right above the seahorse's head, that's the fornix. So it goes corpus callosum, septum pellucidum, fornix. And then we're on the seahorse. Okay, so now we're on the thalamus. What part of the seahorse is the thalamus? It's his head, right? So we're going to look more at the thalamus. The intermediate mass is the eye of the seahorse. Get two seahorses here so you can see the differences. There's another seahorse. There's the intermediate mass on that one. For the geniculate nuclei, these are on the outside of the seahorse's neck. There are these two bumps right here. The lateral geniculate nucleus is this one, so it's more lateral. If you look at it from behind, it's a little bit more lateral. It's also a bit above the medial geniculate, which is that one, which is more medial and below. So lateral geniculate, medial geniculate. Okay, the hypothalamus, what part of the seahorse was the hypothalamus? His nose. So if I look at his nose here, he's got kind of a double chin going on here. That little bump under his chin, that's called the mammillary body. The pituitary gland is this bubble coming out of the tip of his nose. And you can see that over here too. The mammillary body's not so great here, but there it is, a little bump under his chin. There's the pituitary. For the infundibulum, it's this little strip right here. It's a little tiny tube that connects the pituitary to the hypothalamus. So you can only see it on this one. So you can see it on this one.
Dr. Beck?
What?
What is that called? I'm sorry.
The infundibulum. So you can see it actually very well on this one. So there's the mammillary body. Here's the pituitary gland. It's this ball hanging off, and this wire is the infundibulum. Okay, for the epithalamus, this is the seahorse's hair. So it's just the top of the thalamus. On this one it's pink. Others it might not be a color at all. This one is just where it gets kind of bumpy up here. So he has curly hair. Yeah.
Where's the optic chiasm?
Oh, the optic chiasm. Let's hold on to that. Let's come back to that later when we do the cranial nerve. So I will do that as soon as we get to the cranial nerve. Sorry, forgot to mention that. So there's your epithalamus. The pineal body is the bottom and the back of that, so it's like he's wearing a bun. So there's the pineal body. There it is right there. Okay, cerebral peduncles, we did those last week, so where are those? The lines, good. So the little stripes on the outside of the neck. The corpora quadrigemina, where are we gonna look for those? We did those last week too. Two bumps on the back, so the fat rolls on the back of his neck. Now each bump is called a colliculus. The superior colliculus is on the top, and the inferior colliculus is on the bottom. Colliculi is plural because you have one on each side. For the cerebellum, here's the cerebellum right here, or right there. Or right here. One hemisphere, two hemispheres. Now if we put them together, you'll see this little worm-like structure between the two, and that's called the vermis. So you need to have two cerebellar hemispheres together to see the vermis. The cerebellar peduncles are axons that connect the cerebellum to your brainstem. I'll ask it on this brain. If you flip it over, it's this. So it's like a tree trunk.